Okay, now let's get started with this exercise. So in this case study, we're going to run some exploratory analysis of Shakespeare's plays. And so what I would like to do is first to get into, to see where I am. Okay, so right now I'm on my home. So normally when you get there, home directory is where you are. Now, I do want to go to, for example, it depends on where you want to go, okay, where you want to make your working directory. So for now on Mac, there's a desktop, so I'm going to cd to desktop, and then I'm going to make a new directory, okay. I already have a Shakespeare Shake 1. Now I'm going to make a Shake 2, okay, because this is my second try. Okay, so I make a new directory called Shake 2 for the Shakespeare's collection, and then cd space. And so, okay, one thing I want to show you is like once you type sh, you can hit your tab. I hope you can see my keyboard. If I tap it, it's going to automatically complete that for me. Because there are actually two shake, there's shake and shake 2. So I need to finish with 2, and then I can hit enter. Okay, so tab is a very useful tool, key on command line, because it will help you automatically finish your command or file name. Okay, so now we are in Shake 2. I'm going to copy my URL, and so I'm going to use this wget command, okay, and run this, follow by space and this URL, okay. Let me post the URL also in the chat so you have it, okay. Let me put it in chat. Okay, so you have the URL in there, and wget is going to kind of get the data and save it as a local copy. So right now, if I just run ls space -l, it's going to show me the data is in there, right? So you see the data. Now let's do some basic processing. Okay, so I only have 15 minutes. I will try to catch up with the time. So obviously you can use cat and then shake. Okay, again, you want to type space and then S, it's capital, so it's case sensitive, SH, and then tab. Okay, once you type partial name, you can use that tab on your keyboard to finish it. Now obviously the file has too much content to be shown on the screen. You can do it, but I would rather pipe this to another command called head. Okay, head allows you to kind of only keep the top portion of your file, and so if I use 5, it will keep top 5 of the file. Okay, so if you use head -5, it's going to show you the top 5 lines, including the headers, right? And you also get to see what are in there. Okay, there's a data line, there's a player line, number, action line, player, and player line, which is the actual text of the writing, right? So we know we have these. Now what is our first task? To count the number of lines, okay, which is very simple. How many total number of lines are in here? Okay, so okay, there's one more thing I want to get to. So once you are on command line, see you are on the new prompt, and you want to go back to your previous, you want to reuse the previous command, you can use, hopefully you can see my finger on my key, okay, there's an up button, okay, so up key, okay, if you go up, you will go back to the previous one, and then go back again, and so you can use up and down to go back to your previous one and revise them, okay, you can revise them. And so I'm going to revise them. I keep the cat, and then I'm going to use wc-l, wc space -l, and then that will count the number of lines for me. Okay, so again, this is using this mechanism I discussed, right? The pipe, to get the output from one command and send it to the input. And so this wc will get the input from the content and then be able to count the number of lines. So there are 111 lines of text in this file. Now let's go to the second task. right? Which is count the number of plays. How can we do count the number of plays, right? So remember there are different, um, you know, columns in there, and play is the second column, right? So there's a great tool called AWK that is great for kind of isolating the columns, right? So if I use awk-f comma, right, because the comma is a delimiter, and then followed by two single quotes. Okay, make sure it's two single quotes, and then inside the single quote you want to put a pair of curly brackets. Okay, and then in the curly bracket you want to print $2. Okay, $2 is a reference to the second column, which in our case is the play column, because we want to count the number of unique plays, right? And so let's do it. But instead of output everything, right? Let's also do a head. You can try to output everything. Let me output everything for you. So it's lots and lots of data, but you see that it has been only the second column play is retained, right? Everything else is gone with this awk command. Okay, now with awk, right, we are not interested in the total number of lines here. We are interested in the unique plays. And so how do you get to the unique play? Of course, first thing you need to sort them, right? Sort the list of plays here, and then after sorting you want to pipe this to unique. And remember, when you do the unique, it's going to merge all the plays. So all these duplicates, right? You have lots of duplicates because, you know, one play has multiple lines. And so it will be merged into one. Okay? And so let's try to do it. So if I run unique, it will merge everything into unique plays. So let's run it. Okay? And so as you can see now, it's no longer a long list, but just a list of unique plays. And so again, let me show you this command here, okay, by use the up button, up key, okay, arrow key. And so so you have the unique plays in here, and if you want to count them, continue to pipe. Okay, so again, use the vertical line, pipe to WC-L, and there are 37 plays, which is consistent with my understanding about this data set. Okay, so this is to count the number of unique plays. Now, let's go to a even more difficult task. Okay, can we count the number of players per play? Or can we figure out a way to see what are the unique players in each play, right? So let's go for it. Okay, so in this case, it involves two columns, right? One column is play, which is, let me go back to a previous one just to show the original data. So we want to be able to identify players, which is column number 5, okay? And be able to run some statistics per play. Okay, so we're interested in these two columns, number 2 and number 5. Okay, so again, use your up arrow key and go back to a previous one with the AWK. Now, in addition to $2, we are also interested in $5, right? Column 5. Okay, and so let's double check. Head 5, right? So it has player, and now there are some lines without the actual player, but this line has both the play, which is Henry 4, and then King Henry 4 is the actual player in this line. Okay, but there's one thing, because there's a space. When I use this syntax to print, it uses space as separator. Okay, which I don't like because I want to be consistent. I want to use the comma as a delimiter. So just a very minor change here. Go back to the previous line, and if you put double quotes around the comma here, okay, that will make sure it puts a comma in between the two columns, okay, when they are selected. Okay, so if you look at this again, player, between play and player, there's a comma. Okay, there's a comma, even though the second column here, the player column is empty, but there's a column here. Okay, so we can continue to rely on this CSV format. Okay, so this is the first step. Now, the second step is that we should sort, right? We should sort the players. Okay, sort the plays. So we sort them, and then we can identify the unique. Now when you sort them and unique, let's take a look. Okay, so if we output all the unique, you're going to see the play is actually not unique, but the combination of the play and players are unique. Okay, but that is good. So this gives us a unique player for each play. Okay, even though that play name is not unique. Okay, but this is a good starting point. Okay, and so we have a kind of unique, a list of unique combinations of play and player. Now we can continue to use this to say that, okay, really right now I want to be able to identify how many unique players are in each play. So right now, the number of unique players in each play is equivalent to the number of repetition for the play, or duplicates of the play. Hope this makes sense. And so in this case, I'm going to single out the first column, which is the play. Okay, again, we follow this -f comma because comma is a delimiter. And then I'm going to use print $1. Okay, because in this format, the $1, the first column is the play, and the second column is the player. Okay, so let's that is the okay. So once I have done that, okay, and again, let's output this to see what it does. Okay, it will output all the plays. Okay, duplicated because of the different players in each play. And if I now output this to another sort, of course I believe it's sorted, but it doesn't hurt to sort it again, make sure. And then another unique. Okay, so sort. So normally you see it, sort and unique should be run, should follow one another, right? So unique, and then I can count C. Okay, so it's going to merge the unique players together and then count the occurrences of the duplicates, which is in this case the number of players in that play. Okay, so let's run it. And so you got it. Okay, so for example, Henry IV has 36 unique players. Now perhaps you are interested in the sorting. Okay, and like I want to sort from the smallest number of unique players to the largest number, so we can use sort -n. Okay, make sure, because it's sorted, it will be sorted by the leading number, okay, which is the number of players. So let's do it. Okay, and so in the end you will see that it's sorted. 1 doesn't count, this is the header, but 18, right? And then the largest is 71, which is Richard III, right? So this is to count the number of players. Now, because of time, I'm going to skip kind of 2 tasks here, and I'm going to go directly to. Let me just give you a function of search, okay, rather quickly. Okay, so again, if you want to search for something, right, you can search for example, you know, Brutus. So I want to show the lines of having Brutus, okay? And then, of course, I can output this a lot, but I can also kind of try to put these together and say, okay, I'm interested in the number of plays, the actual plays containing, you know, Brutus. Okay, so I print number 2, right, the play column, and then I can unique. right? I believe it's already sorted. So right now I can unique perhaps dash C. Okay, and that will give me all the place, the unique place containing Brutus, and also this 141 for Julius Caesar is the number of occurrence of Brutus, right? Which should make sense, right? So this is the third task. Let's get to the final task. Okay, I may be just a couple of minutes out of time, but bear with me. Okay, so now let's see if we can do some basic term processing and be able to identify term frequencies, like how many times a term actually appears. You know, we want to identify all the unique terms in this entire collection, and then the number of times each term occurs in that text. Okay, so let's go for it. So what I'm going to do again, of course, cat Shakespeare. Okay, and then what right now, remember, if you remember, the last column is actually the line, the actual text we are interested in. So what I'm going to do is just to print $6, okay, which is the last line. And once you have done that, okay, I can give you, you know, this data. So it's all about the text. Now, I don't want to see the quotes, okay, because I'm not interested in the quotation mark. So let's use regular expression, Perl, right, with the inline. So Perl PE. If we pipe to Perl PE, and then we can search for the quotation mark. Okay, so search for quotation mark. Now this is not a special character, but if you want, you can escape a quotation mark with this. This is /, right? And then I want to remove them. Okay, so after the second slash, okay, nothing in there because we want to remove, and then G. Okay, so if you do this, you will see the quotes are removed. Now let's continue to pipe to another Perl. Okay, and there's one thing I want to do, okay, which is to reduce everything to lowercase. So let me just show you the syntax. Okay, so again, it's a dollar underscore equal to LC. Okay, this is kind of a replace itself and convert that to LC. So if I'm only interested in the lowercase form of each word, right, I can do this. And if you take a look, it converts everything into lowercase. Now we can start to do tokenization. How do we tokenize? So we want to find the punctuation and then convert each punctuation, whether it's a space or comma or whatever, as into a new line. Okay, and that will basically put each word into one line at a time. Okay, so let's do it, and I'm going to do this Perl PE, and then what I'm going to do is S/, right, and then there is a syntax for this is a bit tricky, but I will explain. Okay, so punctuation and then /s and then plus. Okay, so this is looking for punctuation, the kind of the word boundary and space. Okay, either one, and then as long as they appear. Okay, so either is a punctuation, a period, a question mark, or whatever, or a /s, which is a space, white space. Okay, and at least if there's one occurrence of that kind of word boundary, we want to replace it with, so there's a slash, and then there's a kind of a different slash, and this is to replace it as a /n, which is a new line character, and then /g. Okay, and that will kind of replace everything into separate words. And so let's take a look. Okay, and one word at a time. Okay, so you see, entire text is kind of converted into individual words, one word at a time. Now let's sort them. Okay, so if we sort them, it will be a sorted list, and then we can use unique-c. Okay, now this process actually will take Actually can be quite quick. Okay, let me try it. Okay, it's going to sort them and then do the count. Okay, and then now let's say, okay, actually I want to do the count and then sort again by the number, by the leading number, because the leading number actually indicates the number of occurrences for each term. So perhaps I'm interested to find out which one actually appears the most time, right? So I can sort them. And so if I sort them, right, and it's a number, so dash n will sort the words, and if I press enter, it's going to sort the terms in the increasing order of the term frequency. And I hope the bottom of the list makes sense, right? Because it looks like the, which is the stop word, appears 20,000 times, and to, I, these are very common words, and it makes sense that they appear so many times. Now, sometimes it may take longer to compute, and so there's another way to redirect. So if you want to save the data to a file, let's say, okay, these are term frequencies. So I can use this greater than tfs.txt, right, to save all these term frequencies into a file. Okay, so with that, you can get this done, this word tokenization, which is a very important step in information retrieval and text mining, among others. Okay, so you see, if you know the power of these individual commands and know how to combine them together, there is a great use case for of analysis, especially when it comes to text. Let me take a look if there are questions already. So yeah, okay, there's a question here. Why do we have numbers as words in the head? Yeah, they are, because these are also, because it doesn't matter. What we did was that we used the space and punctuation to separate the kind of the symbols out. So sometimes if you have like 20 and then space something, right? That 20 also is also counted as a word. So there are some ways if you want to filter out the numbers. Remember, there are also regular expressions that allows you to do that. So you may want to be creative and think about potential use. If you do not want numbers, yes, there is perhaps one more thing in your pipeline to remove those digits, okay, if you want. But good question. Let's see. Okay, are there any other questions? So thank you. I'm going back to cheat sheet. Yeah, yeah. So cheat sheet is one thing you can do, and then yeah, again, don't have to remember anything. Just roughly know them, and also ChatGPT or other AI tools, or even Copilot. I believe as part of GitHub, can be your great friend because you can ask them about the specific commands.